So, hi and welcome everybody for the SUSE QE Tools workshop on the 22nd of March 2024. Today, we would like to go through the validation steps and best practices that we collected for multi-machine test, setup, debugging, and OpenQA document. The whiteboard is a feature of it had been there for some time. Right. Going to hide it. Do you still see this whiteboard now? We shouldn't need
We
it right
see
now.
your screen share.
Yeah, that's fine. Okay. So right. So what we can do is we can go to the OpenQA documentation, and in the documentation, what you can see there. Zoom in a bit. In the table of content, there is setup, and then the user's guide, and then what we are looking for is the test developer guide, because in there we mentioned writing multi-machine tests, and that one describes what is needed to run the test and how to set up the test. And in the separate section about networking in OpenQA, we have the multi-machine test set up. Since some months now, we have an automated setup provided, also ordnance setup multi-machine. So anyone setting up the system can use that. That basically should bring for open state. You can rely on multi-machine capable networking. However, something can always break, and it's a good idea to verify that. This is why later we have this chapter about verifying the setup. What I would recommend is actually to verify the setup with OpenQA test. So for example, for that, use ourselves as part of a continuous monitoring multi-machine scenario where we are having a simple ping between the server and the client, or there's also a wicked basic graph and test cluster that's more elaborate and quite helpful to identify also if the network of the test environment is capable enough to provide everything that's needed. And side note, this example of OpenQA clone job also shows how you can set specific test parameters for the individual jobs in a cluster. So for example, here you could say override worker class on the cloned job, but for wicked basic ref, I want to add worker foo worker class, and for wicked basic stud, I would like to set a different setup. So that's one thing. Let me show this scenario quickly. So for example, here we could just say go to test match in client. And you can see that we have in every tumbleweed snapshot, for example, we have this scenario and pretty stable. So, we can assume that this works well enough. What one can also do is try to verify the setup manually. So you can also start virtual machines where you supply more or less the same parameters that the OpenQA tests are also relying upon. So for example, here you can here you can just download a minimal virtual machine and start that. And relevant parts here is if you do that on one of the workers, you're selecting an interface hub 40. I will also show that how that looks like on one of the production cases where you have those specific virtual network interfaces. So here we are using that one, and you should assign a unique MAC address, so not one that's already by any other test currently running from the virtual machine. And what you can then do is you can set up. So in this case, when we do that, then don't have a network from the beginning, and then you can set up the network. For example, set a lower MTU size when you're expecting that you want to go in, depending on the setup, you want physical machines which are separated, like in our case, we have purpose of redundancy. We have physical workers which are in different data centers connected on an IPsec tunnel, and hence we accommodate the packet size accordingly. Adding a local IP address and a server, and for the purpose of just connecting outwards connectivity, we can just rely on an external name server. And another thing is the Open vSwitch configuration. So what you can do is check if forwarding is enabled, and then there are multiple tools which I would also like to demonstrate, which can show the different configuration and also the flow of packages and the statistics that Open collected itself. And then you see an output like this one. What else is there? You can check the firewall, of course, to there is anything passing firewall or talking. Then there is a section about debugging tunnels and MTU sizes. Mentioning a special ping command. So I guess most of you ping, and ping can take different parameters. By default, ping is using the ISM protocol with a smaller packet size just to check if there's anything going through. But what one can also do is select a much bigger packet size and ask to prohibit any fragmentation of packages, and that can help to find out if there are any problems with. Then we have the same scenario, but a bit more elaborate when you have a virtual bridge connecting. So this is more like what we only have in a setup, and the according output from yeah, so that's the part about Open vSwitch. I would like to only look into that. There's also base network which can work in theory, but we don't actually use that in our environment, so it shouldn't be relevant. So let's see. I would like to open a team session live server and share the screen. So yep. This link also trying here. How can I select that part of this? Yep. Good enough?
Looks good.
All right. So so we had been showing OpenQA OpenSUSE org. Let me log in there. And then what we can see under workers is the current workers that are. And what we can see is, let's select all because there might be, well, they're 61 busy, so they're currently working. You can see we have multiple AH64 machines. They show up first because of the A. And then we have OpenQA worker ARM. also AH64. We have the OpenQA worker 21 and going on. And you can also see what we commonly provide in the worker class. I mean, the normal worker class that you would use is either Chemo x8664 or Chemo i586 for 32-bit test. But there's also the tab class showing that this is a multi capable worker. There are also other classes, and then we have those classes which probably we will change a bit to give it another prefix. But basically what we want to show with that is where this machine. So there's this data center in Prague, and this is denoting location actually down to the rack. So A12 is the rack that this machine is located, so that you can either fine-grain a selection of the tests if you have special requirements, like I want to be really near to another resource which is in that data center, then it's possible to connect that, or maybe just for debugging and identification. But I would not. You can see that this list goes on, and then if you go to the end, basically we see that like that. So we have 21 up to 25 that are currently. There's also 26. I don't. There's also Chemo Power PC. Yeah. So let's go back here. I'm going to. Wait, where's my type? I think so that's the open QA open SUSE org instance, and then I can check like this. Host for my. Let's see if we can reach all those hosts. I guess not all of them are currently online. Yep, 20 not online, affected, and 27 and 28 are currently not connected because they're reserved. But for the others, you can see. You can also see here, this is what I mentioned, like the default of ping where we can reach those work. So maybe we can also try that out. Can we actually connect the other physical hosts before we try to do any further level down debug? So first, so which one goes not there? There. And now let's try that again. Preventing fragmentation. And what was the -S? So let's try that with 100. And you can see that all worked. We received the response from all of them. If we would select something like 1500, you can see that's actually not possible. So the message is too long, MTU 1500. That's also because there is the additional overhead that we need to account for. So this won't work anyway. What happens if we select something like 0? Then you can see that we are below the limit. And so this still works if you actually approach the limit 1472. And if we would, so the other direction, add one more, then that's this is actually not possible to do. Now let's go to any worker, like worker 26. Let's take a look in the there top workers class. Yes, there is. So you can see that this machine is generally good for multi networking. And let's see what's currently running on there. So you can see there are a lot of processes like let's count for EMU processes. So there are 8 EMU virtual machines currently running, and those are executing. Let's not interfere with them. Let's do our debug. So what can now I would like to those commands. So first, for a machine where you would like to allow that virtual machines can, from that running on that physical host, can reach an external network. That's what we commonly do with OpenGA. Then we need forwarding. So let's check that, and we can see that we have a bridge 1 and an ETH0, and both of them allow forwarding. That wouldn't be enabled, then that can't work, right? I think that's configured in this file. So that file 70yas.conf means that very likely this forwarding was enabled during installation by the YAST installer. So how did we install that machine? We installed it with an AutoYAST profile and selected the system role, have a hypervisor host, and that's when the YAST installer by default adds those forwarding for both IPv4 and IPv6, and also adds an according bridge device. So if you go from the top, then you can see that there is this bridge 0 device with the MT 1500. Then there is their physical Ethernet devices like ETH0 and ETH1, where ETH0 has a carrier and is currently used, and ETH1 is not connected. That could be connected on or another network. You can see that there are also other devices like OVS system and BR1. Those are controlled by Open vSwitch. So, after the installation of the system, basically you have the loopback device, obviously, then you have ETH0, ETH1, 0 on that system. Installing OpenGA and other instances, including the Open vSwitch package, will pull in Open vSwitch, and then if you set up the multi-machine according with the OpenGA multi-machine setup script, then this will create the according services and configuration so that also this virtual bridge controlled by Open vSwitch is created. And then we have a yes, Anton?
Bridge 1 command for Open vSwitch and bridge 0 is just for regular OpenGA.
Sorry, I didn't get it. It's a bit noisy. Can you say again, please?
The one that's for Open vSwitch.
Bridge 1, yeah.
Not the bridge 0.
Yes. Bridge 0 is provided by the system, and bridge 1 is used by Open vSwitch. Right?
Yes, just wanted to make it clear.
Yes. Then we have all those tab devices, and you can see that they have all separate MAC address, and you can see that we have tab 1 through okay, so there's some gaps in between, but up to tab 158, so really a lot of them. Additionally, here at the end, you can see that there's a GRI device. And the GRI device are the connections providing an extra tunnel between the between the workers. The workers can reach each other, but what is provided here are extra tunnels which can be used by Open vSwitch to connect virtual machines running on one host, virtual machines on another host, but in a separate, segregated network. So think of a scenario where we would run a DHCP server and a DHCP client. That would wreak havoc if you would just do it within the production network itself by providing some rogue DHCP server, but with the setup, you can safely do that within OpenQA multi-machine test. Okay, let's try out the next command. So there's OVS VSCTL show. That one shows bridged and the top devices are assigned to it. So let's try it out. So the output is a bit too big. So limited. So what you see here is that this bridge 1 was mentioned, and to this bridge, the tab devices are connected as well as multiple GRE devices. So you can see tab devices and then GRE devices with the, and also BR1 is connected itself. So the GRE devices are the connection to the other hosts, and then the tab devices. This looks correct because the devices show up, and also you can see that the GRE devices have an IP address which is configured. Those devices should be reachable. So let's try it out. Is there actually something behind? Yes, there is. Can we identify that host? Yes, we can. So that's down worker 26, and that one is OpenQA worker 20. So that makes sense, right? They're connected to all the other hosts. What comes next? OBS OFCL dump flows BR1. So that one should show us some statistics, and you can see you have an entry where that's okay, big wall of text, but what you can see here is that there's actually something going on. And if let's take a look to the end, that here, for example, you can see that there is something related to a certain tab device. So let's say you have a virtual machine running which you either started manually, or you know which multi-machine test was running on which tab device. Let's take a look. We can actually look that up from the OpenQA instance. So we could look it up from, assume you want to debug a failed test, then you can start from there. Or in that case, because I'm on OpenQA worker 26, I would like to take a look for worker 26. And then let's take a look for the first instance. And then we can see that there was, okay, so these are not really multi-machine tests, but how should I
The
be able to?
previous output, there's no indication that multi-machines jobs running on this machine right now.
Yeah, could be. I would just wanted to show you how can you find out which tab device was for a certain test. So here, if we take a look in this job, and we're looking for tab, then you see the QEMU command line, and you can see that this test, which was running on the first instance, was using tab 0. I mean, would have thought that, okay? So it actually starts with 0. So the first instance corresponds to tab 0. Tab 20 then corresponds to the worker instance OpenQA worker 26:21. Okay, and you can actually see that there are packets passing through, so you can see that there is some action and that there is traffic. Okay, so this works. Let's go to the next step. We can call OVS DPCL show. So DP stands for data path. but more I don't really know. But what you can see here is the connection of the tab devices to individual ports. How is it called? I don't know what you need those ports for. Likely the next command. Okay, the line. Dump flows. Go. I don't really know what that means. Maybe it was like the most one. Yeah. What you see here is a specific Ethernet address. I don't know. Maybe that can also take some parameters. OVS dpctl is the current command. Dump flows. Right. I can select a certain data port here, like 95. But that data path currently not found. Maybe it's pulled tomorrow. Or maybe it really needs a test. Could be. Next one I wanted to show is the appctl command for RSTP show. And that one is relevant for the and STP show. So STP show is relevant for the grid tunnel connection. What we have set up, that's actually set up in wicket scripts grid tunnel pre-up. In that script, what we do is we set up one tunnel bridge device connected to every other currently running machine. You can see here that OpenQA Worker 26 is commented out because that's the current one. 27 and 28 are currently not used. So that's why they're commented out, and ARM are different architectures. And right now we don't want to look into cross-architecture. In cross-architecture, cross-host multi-machine networking. So those are not connected. But what we have then is GRI1, GRI2, GRI3, GRI4. And we also set here, we set on the bridge, we enable STP. That's the spanning tree protocol. What that one means, of course, we have this star cluster connection where we connect every worker to every other worker. We are effectively building loops, which can be good for redundancy, because if any of those hosts go down or are not available for some time, then this can be reconfigured automatically with the spanning tree protocol. What STP does is it looks at all the paths that are there and then decides if which one is the path to take, and also assigns a certain priority number so that there's always a unique connection between one host and any other that is selected. And so that output can also help. For example, it could be that the state tells you that any connection is not forwarding, and maybe that machine was set up to be crucial, and maybe unexpected that the traffic does drop, or maybe STP is not working properly, and then you're building a loop, and then all of those connections are redundant, and you would see that also in the output, as in like receiving multiple ping responses for a single request. That's good. And the last one I would show is this FTP show command. And what that one shows is that that's the switching table for the virtual switch, like which MAC address corresponds to which MAC address has been seen on a certain port. And as you can see right now, there's nothing going on because there are no multi-machine tests running. Let's take a look. Does it look like there are currently running? If you find a multi-machine test currently running, let me know. Doesn't look like it. Then let's start one. Yeah, so I'm actually would like to restart that Ping client job in the yesterday's Tumbleweed build. That shouldn't harm, but it would be nicer if we actually do that with proper OpenK clone command. So let's try that. Clone job within instance. So this one, does it create an HTTP? Yeah, it runs on this. So I'm giving it the additional parameter skip chained steps. I don't want to wait until the image was recreated. I don't do that. I'm selecting that this runs outside any group. I'm overriding the test name and the build to append a suffix. And what else? Let's override a worker class. Here I don't need to set individual settings for all, but what I can do, or actually, yeah, let's try that. So ping server should run on OpenQA worker. But yeah, let me check it. Yes. QA worker 5 and ping client runs on OpenQA worker 26. So those jobs had been triggered. Also find them here. Already picked up. Okay, I didn't do that properly, so why is it now running on OpenGear Worker 2? I don't know. But shouldn't matter that much, because what we can do now is that those hosts list, and then on all I'm calling that command. Oh, not that command. Tricky here because appcplfdb obr1. That, so this test now running. Maybe it wasn't created in before. Let's see if it already shows that. No, it doesn't. Maybe this only shows up later. Maybe we can find something else. What does the dump flow? And okay, we can see that definitely something is going on. Now I wonder, can maybe not? Maybe I should wait at conclude mission. Sounds good. What is I don't know. I guess it's a good point when we can wait. So this is running on OpenGA Worker 2230. Yeah, okay. Let's go to OpenGA Worker 22. And let's just, yeah, try all of those commands. Yeah, now you can see that this shows on port 34 the MAC address of 52034. If we take a look here in the log file, then we can there's the key command line. Weird. That anyway, we can also take a look on the worker right now. It's in pool directory 30. So varlib OpenGA pool 30. And we can see here command line, and this is the MAC address ending with 0334. Okay, on tab 29. So this is why we have this one showing that on port 34. What is port 34? Let's try that command again. And we can see that port 34 is tab 32. And that's what I tab 29. Yeah, it says tab 29. I don't know how this relates to that. But I guess, how can we?
That is
now
different worker, no?
It worker 22. I guess I was on. I am on worker 20. Yeah. And instance 30, which is this drop. Let's try this dump flows. And again with the port. The port 31 or the other one. Okay, I don't know how that the dump flows thingy works. But let's try again here. So you can see this here. And can we find anything relating to our test in here?
I will run first the first command, so to see what have been assigned.
Let's see. So we have this command, but it doesn't look any different because the tab device.
No, grep for tab tab equal 1, I think.
Again, so tab is tab 29 for this test. Okay, what we can do is here in the IP address output we see yeah, see in tab 29. I'm sorry, it's a bit cut out to here. You can see that this device is up. So what that means, that QEMU is actually using this tab device. Okay, so we can see that from the virtual machine, it's like reaching the hypervisor, and it's using that here. Okay. And then from there on, we can go on to try dump that. Anything in here? Don't just SDP. And we can see now that this tab 29 is also connected. So, and what we could now try to do debug on the other side, on the other host, if also traffic is. By the way, I think there was something mentioned. Here we are setting up. No, the same. Okay, fine. Yeah. So of course we now have a situation here where everything works, but I just basically wanted to say if in any of those steps we don't see that the device is up, or if we don't see the device showing up here, or if we don't see any flow, or if we don't see the MAC address, then we can further debug in that direction. With that, I would like to stop here. Do you have any further notes or questions? Oh, okay, fine. So then let's stop here. I also canceled the jobs. We don't need those anymore. Then I can point out what's coming up on the next week. So the next week we will skip to the public holiday. Then after that we have the roadmap presentation for the start of April. And after that we will have lightning talks organized by Liv. Liv, how many submissions do you have? And I guess you would still appreciate if there were no more presenters signing themselves up, right?
Yes, it'd be absolutely awesome if people sign up and you don't need to prepare much. Just, think of a topic you want to talk about. That's all we need.
Okay, cool. So looking forward to that. With that, thank you all and see ya. Goodbye.